Cool.
Well,
So let's start on the prep assignment.
yeah. Prep assignment's pretty big.
Yeah, it was kind of lengthy.
Huge. Okay. All right. So, first going into the z-scores, finding them and if they're unusual or usual.
Mm-hmm.
So just first off, for me, I'm restating it. If it's over ever 2 or above, that's what makes it unusual. And if it's like 1.99, then it's not unusual.
Mm-hmm.
That one. Okay. Use the information on the baseball batting averages given in the reading assignment to complete the questions. This is information is found in lesson 5.3.2.2 baseball. And so classify each of the following batting averages either unusual or not unusual. So anyway, basically you just compute what the value is with that 1.90 with the mean of the 0.261, and then the standard deviation was 0.034 to find that first one. Any thoughts? Should we just keep going?
Yeah, you can keep going, I think.
Okay. Okay. Let's see. So just the same thing is, okay, for that unusual one, I got the 2.088. And then I just skipped ahead to the next questions because I knew what that was. Do you guys want to, someone else want to pick up B? We can just do it together, or you guys do it, or did
We can
someone?
just go over is the A's unusual, B's not unusual, C's not unusual, and D's unusual.
Yeah.
I agree.
Mm-hmm.
Sounds good.
Okay, for number 2, I find the probability that a randomly selected professional baseball player will have a batting average that is greater than 0.335. The probability that is 0.015.
Yep.
Yeah, and so with that one, like I had to first find the z-score and then put it into that applet and unshade the area. Did you guys go ahead and do that?
Yeah.
Do you know what I'm talking about?
Yeah.
Okay.
Well, we have
Just
an
FYI.
applet for like quizzes and tests.
I don't know.
I don't know. I would assume so if they're wanting us to use it.
I asked Soraya, and as far as I remember, she said yes. Like, we'll be using that. Also, with that, just make a note that this is a type or this is an exam question, she told me. So, like on our first exam, she just said you'll need to be able to do that, you know, find the z-score, plug it into the applet, and just super simple. But she just made a note of that to me, that it was an exam question.
Cool.
Or one just like it. Okay. Provide a brief description of the normal density curve. Describe the shape and the properties. Okay. Oh, so it's just a bell curve.
And it's symmetric.
Yeah. Just going up and down.
Yeah, and it's called the mean is the exact middle of it, I think.
It's determined by the standard deviation.
Mm-hmm. Yeah.
What was that, Nana?
It's determined by the mean and standard deviation. That's how you get the shape of it.
Okay. Number 4, in the following z-score formula, please state what each symbol stands for in that.
Okay.
So Z is the standard deviation, which says that it's away from the mean. A certain observation lies. Someone can go on for a second. We have a little person. Okay, just sit. I'm going to make her another bottle.
All right, no worries. Okay, well, what I had was X is just the z-score, or Z is the z-score, X is the what we want, U is the mean, and the O thing, theta something, is the standard deviation.
That's what I have.
Okay. I'll read number 5. In no less than 3 sentences, please define and describe the 68, 95, and 99.7 rule. So for this one, I think I put the 68% is the middle, which is from the first deviation, positive and negative from the mean. And then the 95, where the 68% of the information is in that 68% range. And then 95 is the second deviation, both ways away from the mean. And then the 99.7 is the third deviation, positive and negative away from the mean.
You guys still discussing 4? Are you on 5?
We just did 5 because it's really just an explanation.
Yeah.
Sounds good. Yeah, just defining that.
Number 6, the mean of all quantitative scores on the GRE is 150.8. What is the standard deviation with the standard deviation of 8.8? It says scores on the quantitative portion of the GRE are approximately normally distributed with mean, which is 150.8, and standard deviation is 8.8. It's kind of a very easy question.
Yeah.
Okay. And then when it says what proportion of the people who take the quantitative portion of the GRE will score above 165, and that's when I just did the 165 minus the mean of 150.8 divided by the standard deviation of 8.8, which gives you the 1.6136, and then plug it into the applet, highlight that right area, which gives you the 05330.
Yeah, because that's demonstrating that it's above that z-score.
Yeah, because if it was below, you'd go to the left side of it.
Yeah.
I've got that. I understand.
If a student scores in the 10th percentile, what would the corresponding z-score be? The z-score would be the negative 1.2816, right? Is that one right?
That's what I got. And on this one, we just do the opposite, right? We click on the left.
Because it's a negative.
Yeah.
And then...
Well, if it's less than 50%, then you click on the
far left.
The far left, yeah.
10th percentile. Okay. I understand that.
Okay. And it's not usual.
It's not usual because it's
not
unusual because it's not over 2.
Mm-hmm. So it's good. All right.
That wording is kind of tricky. The unusual, not unusual. Why don't we just call it usual? I don't know.
Yeah, that'd be.
I'm sure there's some reason they do that, but it's like, anyway, those oxy, like double negative.
Yeah.
And then the quantitative GRE score for a student who scores at the 10th percentile would be 140.
Mm-hmm.
Yes.
All right.
Eddie, why don't you go for one?
Sure. The mean speed of hydrogen at room temperature is 1800 meters per second, or something like that, with a standard deviation of 600. At room temperature, the mean speed of hydrogen, H2 particles, is approximately normal, with a population mean of 1800 meters per second and a standard deviation of 600 meters per second.
Mm-hmm.
So what is the probability that a randomly selected particle has a speed over 2500 meters per second?
So here we're just plugging in the two numbers.
Mm-hmm.
Yeah, just into the applet thing.
The value and the mean. The 1800 and the 600.
Yes, that'd be the 2500 minus 1800 divided by 600 equals that 1.1667. And then you could plug that into your applet and you get that 0.1217.
Mm-hmm.
Okay.
All right. So for C, it says, what is the probability that a randomly selected particle has a speed that is less than 2500 meters per second? And so from this one, I just subtracted the, what's it called? I just had a brain fart.
It's the same thing as we did in the last one, exact same thing. But when you go to the applet, you just shade in the far side, the far left side, right?
I think I just subtracted.
Yeah, 2500 minus 1800 divided by 600 equals, again, that 1.1667.
Mm-hmm.
And when you go to the applet, instead of going to the right, which would be above, you're wanting to go less than, so you go to the far left side shaded area, which would be the 0.8783.
Mm-hmm.
Go.
The next one, I actually, not this one, E, I have a question on.
Okay.
So I'll do D. It says, what is the probability that a randomly selected particle has a speed that is less than 1500? So I did the same thing with the 1500 minus 1800 divided by 600 equals negative 0.5. And then you shade in that area again, and it gives you the 0.3085.
Mm-hmm.
Is that how you did it too? Okay.
Yeah, that's how I did it.
Wait.
Yes.
Go get it. Sorry, I'm going to mute you guys so you don't hear my kids yelling.
They're not bothering me.
Are we in E now?
Yeah, we're on E.
Okay, I'll read it.
Okay.
What is the probability that a randomly selected particle has a speed that is between 1500 and 2500?
Okay, what's the math on this one?
You subtract E or C from D from C. Because we found the area of the 2500, and then we found the area for 1500, so you just subtract them.
So you do
15 from 2500?
Yeah.
The area.
or points. Sorry. So you're saying the area or the 0.305 or 85 minus
You do
the
0.8783 minus 0.3085.
Okay, opposite. Okay.
I'm confused. I don't understand. Sorry.
Okay, so I actually watched the videos this time.
I didn't get to watch them yet.
So since the first one we found the probability that the speed is less than 2500 meters per second, and on the bottom one we found the probability that a particle is less than 1,500 meters per second, then we just subtract them since we found the 2,500 and below, and we found 1,500 and below.
So the
So we want-
2,500 and below, are we using that 1.1667?
No, we're using the area that we found.
The
So you put that in the
7?
z-score on the applet, and on top you'll put the area, which is 0.8784.
Yeah.
0.8784 over,
Or minus.
Minus
minus
the area of the answers that we found on C and D. Those are the areas.
Okay, so it's the 8784 minus 308.3085.
Yeah.
Okay. And that would give you. Hold on. I was like looking at this and I just skipped over it because I didn't understand it, and I thought we could just talk about that one.
Mm-hmm.
Well, and that's not in the z-score formula. That's just you just minus that and then plug it into the applet. That's correct?
You just subtract them. You don't have to
You
do
don't-
any
or
plugging.
that's
You
what I
don't
mean.
have to do the applet, right?
No,
Okay.
I don't know if it would be different if one of them was greater than 2,500 meters per second and the other one was less than. But on this one, I guess I just got lucky because I got the right answer. I'm gonna try to see what I can do here. 1.166. Oh, so I don't think we can do different z-scores, can we?
Not on the applet, I don't think so, because they have to.
Yeah, I was trying to do that. So I think
know,
we
I
just have to do subtraction.
Yeah, I was just trying to move it, and I'm like, I don't think you can, because whatever you put on the right side negatives, or whatever on the right side negatives to the left, so it's an even area.
Mm-hmm. Yeah, so I can see. Yeah, so since the first one was the middle and the left, you subtract that from the left, and then you get the middle.
Okay.
Yeah. If you look at the applet, it makes a lot of sense that way.
Okay, I'm a little lost. So you guys are that 0.5695, that minus, is that what you're putting in? Where are you putting that into the applet? That's not the z-score.
0.96. Where did you get that number?
Or sorry, maybe I'm on. Are you guys doing F?
No.
No, we're not on F yet.
We're doing
Give me
E
the
still.
point.
We're just explaining E, yeah.
Okay.
Do you get E?
Well, E for me, the 0.5698.
Uh-huh.
But what are you talking about with the applet with it? I mean, for that question.
Oh, because if you look at the applet, the first one is including the left and the middle, and the second one is just including the left. So you subtract the first one from the second one just to get the middle part of the area.
Okay.
It's
Got
just
it.
simple math.
I understand.
Okay.
Got it. I just wanted to know what you guys were talking about with the applet. Now I know. Okay. F.
Yep.
What is the third quartile of the speeds of hydrogen at room temperature?
Okay, so
Okay.
the F score for that, or the Z score was 1.16, right?
Is that what? Where are you finding? Was that in the text?
We had to solve that to answer the
Was it
questions.
for B? Because it says on A,
Z-score
it just
was
says,
0.674.
what is it?
Let me, so it's X equals 1,800
That's U is 1800.
Yeah.
Oh, okay. Going back to the hydrogen, question 7. I'm going off of that.
So what is the math on this one to figure it out?
So, well, we need to figure out what x is for this one.
Oh.
So you guys are first doing or Catherine, finding this, or the z-score, implementing the 1800 and the 600.
But then we have 2 unknown variables in this.
So the Z, you put in the third quartile, which is 0.75 on the applet, on the area on top. And it'll give you the z-score, which is 0.674.
Because I put in 1.16 as the z-score, and then I got the 0.75 as the area. But I'm wondering if we use the same z-score from the previous examples. You know what I mean? Because on one of them the z-score is negative 0.5, and on the other one it's 1.1667.
How would we know?
So for this one, like the little graphs that they showed, you just put like either 10% on the top or 90%. On this one, you just put 0.75, and you get the z-scores, which is negative 0.6.
I get what you're saying.
I need more help explaining that.
It's positive.
Did you get a z-score of 1.15?
0.674 is the z-score.
You sure? Because on the area I put 0.75, and the z-score shows up as 1.150.
You sure?
You put 0.75 in the area?
0.75?
I put 0.75.
I get 0.319 if I put in the area, or this is the normal probability.
Okay. Did you put in the lines in the middle first?
No. Are you supposed to put the lines in the middle?
Yeah, well, that's what it showed on one of the problems. And then you just put 0.75 as the area.
And you got 1.150?
That's what I got when I put it in. It's probably because you have different areas shaded.
I have the left 2 shaded, which is this 0.75.
If you shade the middle area?
Only the middle?
Yeah, and then you put in
the middle, it's 49.97.
But 0.75.
Okay, 0.75. Okay, so we are looking for, let's see what we're looking for.
That's when I get that 1.150.
Okay, yeah. So I think we're going to shade both of the side ones.
Only?
Both of the left, because you want 75% of that graph.
You want the left side or the right side?
You want the left side.
Wouldn't that be Q1?
Okay. Well, yeah, no, it goes, don't you want the right and the left? Because quartile Q1 is the first standard deviation left and right. Q2 is the next standard deviation left and right, and then Q3 is the standard deviation left and right.
But if you're
what is the third quartile?
So I think we're doing 0.25.
Because the whole graph is a 1, right?
Let's see. Yeah, hold on.
The whole graph is a 1. The negative 4 is...
It's a very top point.
When we're doing... Hold on.
If the negative 4 is your minimum and the positive 4 is your maximum, that first line would be your... Is that first line? Well, there's not 3 lines. There's only 2 lines. So where's your Q3?
Okay. But with that,
Okay. Dang.
I'm kind of lost. I'm not sure what the third quartile of speeds of hydrogen at room temperature, and then we were plugging in that 0.75, and we're trying to find the third quartile speeds. But I'm not coming remotely close to what the answer key says. Is anyone getting closer to have an idea?
I'm doing one right now. We'll see what it is.
What if you put into that z-score on the applet? If what happens if you put 0.674?
0.674. I just
You
put
get
it
an
in.
area of 0.5003.
And shade in the left too.
So the middle and the left.
That's 0.7498.
Okay, so that's
that
about
close?
0.75. That's what you wanted.
Oh, because that's close to the third quartile, the 75%?
Yeah,
Is that
the
what you're
75.
saying?
Yeah.
That's why it's weird. If you put up there on the area and you put 0.75, you should get the z-score of 0.674.
That's what I have.
I'm not getting it.
0.75.
That's what I have. If you shade in those areas.
That's what I've got.
Yeah, I get a z-score of
Okay.
0.74 if I put 0.75 with the two left ones shaded in.
Okay, good. So that's your...
But I plug in that z-score into the formula, and you don't get the right answer.
So you
So
put
how...
0.74 equals x minus 1800 over 600.
Oh, maybe
See,
it's because I put 1,000 instead of 1,800.
Okay, what was the math on that one?
0.674, which is the z-score,
That's right.
equals x minus 1800 over 600.
That is right. So 0.6. So let me read the question again.
Okay, and how did you find the x?
So x, you just divide by 600 on both sides. Then you, since the 600 is canceled out on the other side, you subtract or add 1800 from both sides now. And you should get, on the left side, 1800 plus 600, in parentheses, 0.674, because you're going to multiply that, equals x. And then you get the answer which is 2204.4.
Yeah. I just multiplied 0.674 times 600 and then added 1,800 to that, just to isolate the x.
Yeah.
Thank you.
Yeah. I had 1,000 written down, that's why I wasn't getting the right answer. That makes sense.
Okay, you guys want to go on?
Yeah.
Okay. Oh, this next one's pretty easy. Determine whether the data represented in these Q and Q plots are normally distributed or not. Record your answer for each graph. Justify your answer. Okay. So the first one's not normal because it's not going at a slant. It's going like straight up.
Well, it'd be normal if there was a line that went through it, but since there's no line between all the points, it's not normal.
Okay. Well, to make it normal, though, doesn't it needs to be at a pretty well slant the whole way?
It could be normal and be more vertical as well. It just has to be in a line. Like all the points have to be right after another.
Okay. So just in discussing this, skipping down to E, like I thought that E would be somewhat normal, but Soraya was saying that because it has one spot where it is definitely going vertical, that it became not normal at that point. Because it, what did she call it? Almost vertical. Oh, it deviated from that slant. I don't know. Do you guys want to talk about that?
So, like, if there were a couple of them that went up higher, but the rest were mostly in a line, then it would be normal. But since a bunch of them are going out and then it comes back in, that's why it isn't normal.
Okay. So, yeah, B not normal, C was the only, C normal, D normal, E not normal, and then F normal. So like you were just saying, with just a couple, the C is kind of close with going not normal, because like those first three little diamonds, like they're going straight up and then it starts kind of going over. But because it's only just those few spots, you're saying that's why it's not normal. Like it is normal because it gets going just after a couple of those dots.
Yeah, I think so. I got that
understand.
one wrong, but I can see why it is normal. I can see how it could not be normal.
It just is pretty tight. I'm just saying, like, at what point does it become not normal? Because, like, E has, like, 1, 2, 3, 4, 5, 6, 7, 8, you know, like 8 or so of the dots that are pretty much going vertical, and then it starts going over again. Where the normal one, C, just has those 3 spots, and then it kind of starts going on that slant again.
Yeah, I might also be wrong. It might be that it's going vertical, but I don't remember vertical being not normal. Or being, I don't know.
Something about this, Soraya said that we would definitely be on exams, and in just further on in the class, we're going to make a lot of these with the SPSS. FYI.
Sweet. Okay.
So on an exam, it would go in and say, like, create your own, and then we'd have to plug in the answer or whatever from when we created it.
Yeah.
From what we made.
All right. Are we all good with that?
I'm good.
Yep.
Yeah.
Okay. Let's do the homework.
That is... All right, I'll start the instructions.
Okay.
So as instructions, you are encouraged to collaborate with other students and blah, blah, blah. Based on the following scatter plot, how should you classify the distribution of the data?
Not normal.
Number 2, based on the following scatter plot, how would you classify the distribution of the data? And I would say it's normal.
Normal.
Number 1 was not normal?
Yeah.
Sorry.
Yeah, because it goes vertical for so long.
Yeah.
Okay. Okay, I'll read. The data set NASDAQ prints and volume summarizes information on select companies that are traded on NASDAQ. The table gives the symbol for the company's name, the price, and their stock, and the number of shares that have been traded, the volume. Use the information to answer question 3.
Okay.
So,
I'm downloading it since I have the SPSS thing.
I'm going to also just bring it up. I should always have all this prepped, just in case. Before I take a quiz, I always have like it all prepped, like and ready and stuff. Even though they give us like plenty of time.
Okay, I got it.
Mine's still loading. We'll probably need this for the quiz then.
Yeah, probably.
The NASDAQ.
Make sure you scroll down to the SPSS version at the bottom. We're probably going to have to make a graph out of these, right?
Mm-hmm.
So,
Do a Q plot.
My kids are listening to two different things, Wonder Pets and Backyardigans. So I keep hearing these two different like songs.
Do you turn off the PS3?
Okay, I got it.
Can you share your screen so we can see it, or?
Yeah, it's loading really quick. All right. Let me move this
Really
over.
slow.
I've got mine up now.
Let me share my screen. Okay. Where is it? Okay, so these are the plots.
We need to see what the price and the share volume one.
Price, observed value.
And shared
This
volume.
one.
So which of the following statements is most correct? Out of the two variables, price and share volume, the price shows a more distinct non-normal trend, or the volume shows a more distinct non-normal trend.
Plot of share volume, share volume. They're separate here. The price and the shared volume are separate.
But which one shows a more distinct non-normal trend?
Not normal?
Yeah, price look pretty normal, so share volume would be the most non-normal trend, right?
This is the share volume right here.
That's definitely not normal.
So it says which of the following statements is true? It would be out of the two variables, price and share volume, the share volume shows a more distinct non-normal trend.
Yeah. Okay. So question 4, under normal circumstances, a density curve can drop below the x-axis. And that is false.
Sorry, what was number 3?
Number 3 was B. Out of the two variables, price and share volume, the volume shows a more distinct non-normal trend. This one right here.
Oh, okay.
Because over here, this one right here is the price one, and that looks pretty normal.
Oh, okay.
Okay, so number 4, under the non-normal circumstances, a density curve can drop below the x-axis. What was that one?
False. That one's false.
Okay, and then 5, a normal density curve is symmetric. Yes,
It's true.
it's just an answer. 6, a density curve. One of these answers always has a total area under it equal to 1 across horizontal axis, both A and B, neither A or B.
I'd say it's A.
A.
I think it's both, isn't it?
Can
No.
it cross the horizontal axis?
It talks about this in the video.
For
How
a
it
bell?
says for the bell curve, either the curve is above the horizontal axis or it's on it, but it doesn't cross it.
Okay.
I need to watch these videos.
Does anyone have the answer sheet pulled up? Let me download that really quick.
I do.
What was the
I've got
answer
it.
for that one?
It's A, always have a total under it equal to 1.
Okay.
Okay, if the z-score for an observed data value is negative, then which of the following must be true? The observed value is less than 0. The observed value is less than the mean. The observed value is less of 13.5% of the data. And the observed value is less than the standard deviation. Would it be D?
We are on 7.
Yeah.
Yeah.
Yeah, if the z-score of an observed data value is negative, then which of them is
I think it's B.
I think it's B.
It's B?
It is B. And why do you...
Because the z-score it says in the video that it starts at 0, like usually it's 0. So if the value is negative, so on the right it's going to be 1, and on the left side it's going to be -1 of the z-score. So if the data is negative, it's going to be on the left, which is less than the mean.
Yeah. And again, because it says less than.
Yeah.
But it's good to know that it's the mean. Let's see, that was 7. 8, according to the 68, 95, 99.7 rule, the normal distribution rule for normal distribution. I know I need to review this with the book.
I would say C.
Why do you think that, Catherine?
Okay, so 68% of all the data falls within the first standard deviation. 95 falls in between the second standard deviation, and then 99.7 falls within the third deviation.
Yep.
Okay, and so you're saying because it stands within the standard deviation, that's why it's the normal distribution.
Because 95% falls between the standard deviation of 68 and 95. So there's 2 standard deviations of the mean.
Yeah.
Do you guys get that? I can draw it out for you guys if you guys want it.
No,
Can you draw it out for me?
Okay.
Yeah. So All right, this isn't the best drawing, but okay. So that's this right here.
Yeah.
That right there is the either the z-score or the mean, depending on what you're looking at. And so this right here is the first standard deviation away from that, and that's 68%. And then these right here are the next deviation after that, and then that's 95. And this one right here and that one are the third deviation away, and that's 99.7.
Got it. And so that's why it's 1, 2 away from the standard deviation.
Yeah.
Totally understandable when you're looking at it. Thank you.
Mm-hmm. Okay. We are on 9.
I'll read that one.
Yes.
Okay.
The time to complete a standardized test exam in the BYU Idaho Testing Center is approximately normal, with a mean of 70 minutes and a standard deviation of 10 minutes. Using the 68, 95, 99.7 rule, approximately what percentage of students will complete the exam in less than 1 hour?
So this is right here, 70. It's 10, so 80, 60.
What's the math you're doing for it, Catherine?
Okay, so starting at 70, which is the mean. So the standard deviation is 10 minutes. So then one deviation away in the positive direction is 80, and one in the negative direction is 60. And so it says what percentage of students will complete the exam in less than 1 hour. So 1 hour, that right there is at the negative side of the first deviation. So it's going to be on the left of the 70.
Okay.
60.
And, huh?
Which would be 60. Yeah, left of the 70, sorry. Would be 60.
Okay. So I couldn't hear you. Yeah. And so
you guys, keep cutting out.
Yeah, I don't think this Google Hangout stuff is really good when there's multiple people talking.
You don't see me at all?
Can we see you?
Uh-huh.
Yeah, we can see you.
Huh.
Can you see us?
I can't see myself. It's weird.
Oh, no, yeah, we can see you.
I just get cut out. Like, I didn't hear when you were saying what kind of math you did, Catherine. Just taking the 70.
Do you see that thick line
and then
right
the
there?
Standard. Yeah.
That thick line is the
mean.
That's where you want to start your
70.
The mean is the 70. The 60 is to the left of the 70, which is one standard deviation away from that.
Mm-hmm.
So, what percentage of the students will complete the exam in less than 1 hour? So you find let me solve this really quick, and then I will let you know. So you're going to cut them in half. 68. Okay, so I got about 16%.
So what was the math that you did with that?
Okay, so my exact answer was 15.85. So in the bell curve, the middle part is 68%, and then the two slots next to that are the part of the 95 including the 68. So you subtract the 95% from the 68%, and then you get 47.5%.
Okay, just stop there for a second. So you took the 68 minus the...
let me see if I can write it out as I'm showing you. Okay, so you probably can't see this.
Thank you.
Let's see. I'm gonna try to. Can you guys see my pencil?
Yeah.
Yes.
Okay, so this one right here is 60. Can you see that? 68?
Mm-hmm.
Mm-hmm. And are you choosing the 68 because that's where it falls on the standard deviation?
I'm using 68 because that's just the middle, because we're just talking about percentages. It's probably going to be backwards on this. But, so this right here is 68.
Yeah.
And then, so the 95, so you do 95 minus 68. And that is 27. And so half of 27, 0.5. So then there's 13.5 over here, and then 13.5 is over here. Can you guys see that? And then you do 99.7 minus 95, which equals 4.7. And then you do half of that, 4.7. And then half of that is 2.35. And so that goes on both sides of this, 0.35. And then you add these two together. And that gives you 15.85 or 16.
Okay.
Can you guys see that?
Hey, kind of. Hey, Catherine, if you wouldn't mind, maybe after we're done talking, if you could maybe take a picture of that and just text it to us or something and just put question 9 next to it. I'd appreciate it, just so I can look over that specifically for this with this question.
Mm-hmm.
That'd be great.
I'll just do it right now.
Yeah,
so
I didn't even understand that. So yes, take a picture.
Okay.
Well, I understand how you keep taking it and then you're putting the number on each side of it. You're having it, and then you keep putting them, bringing it down.
Was that in the lesson?
No, I learned this in Math 108.
How did you know to have 68 right in the middle?
Because that's what it is. It's 68 in the middle, then the 95 is on the side of that, but that's also including the 68%. And we don't want to include the 68% because it's the 60% is it's not included in the 68%. I really suck at explaining things, but so I will just draw this out and take a picture.
Was that the right answer, the 15.85?
Yeah, the answer is 16. Mm-hmm. And then 2.3.
My 2-year-old fell asleep.
That's cute. Okay. Okay, I'll text you guys this picture so you guys can have a closer look.
Sweet.
Thank you.
Let me scribble this out over here. Because we're just counting the percentages here.
Okay.
Do you guys get it or no?
Just a second. I'm gonna.
It just came in.
Okay.
I got it on my phone. It's not coming up on my iPad, but I know my phone just beeped. Do you guys want to go over it right now, or do you guys want to go on? I'm fine with just going over it by myself, but
yeah, we can go on.
Okay. You guys can just text me and I'll try to figure out how to explain that better. Maybe.
thank you.
Okay.
Yeah, let's go on. An observation was drawn from, the next one's 10, the QQ plot. Okay. I'm saying that it's not normal because it has that kind of vertical thing.
Mm-hmm.
I'm
Yes.
thinking D.
I would say D as well.
Mm-hmm.
Okay.
An observation was drawn from normally distributed population with the mean of 74.45 and the standard deviation of 4.41. If the observed value is 60, so all we do is just put in those values.
Yeah.
So it's the value minus the mean. Okay.
I got
negative
3.15.
Yes.
Okay.
Yep.
All right. I'll read number 12. Shoe sizes for men in the United States are known to follow a normal distribution. If you calculated the z-score of a man's shoe size and found the z-score to be 2.9, what would you conclude about his shoe size? A, the man has an unusually small shoe size. B, the man has a normal shoe size. C, the man's shoe size is 2.9 sizes larger than the mean.
Well, if it's over the 2 point, then we know that it's unusual or not.
It is unusual.
Yeah, that it's not usual.
Yeah, so I would say D, the man has an unusually large shoe size.
Because it's large because it's over that 2.0.
Yeah.
And if it was negative, I would say he has an unusually small shoe size.
Totally. Okay. All
right.
I'll read the next one.
Okay.
The SAT and the ACT are both aptitude tests designed to measure students' reading readiness for college. They are different tests with separate scoring systems, but they measure the same abilities. The highest score possible on the SAT mathematics section is 800. The distribution of SAT scores is normal with mean 500 and standard deviation 100. The highest score possible on the ACT mathematics section is 36. ACT scores are normally distributed with mean 18 and standard deviation of 6. Use the information to answer questions 13 and 14.
Okay. Okay, so we have to find the z-score for both of them.
So Eleanor scored 680 on mathematics part of SAT. And the SAT mathematics section is 800.
So
The mean is 500.
yes. What was the value? The 800? No, section. Is the 800 the value?
No, the value is 680. The 100 is the
right
standard
there.
deviation.
Okay.
Minus 6. Okay. So for 13, I got Eleanor's z-score is 1.8 and Gerald's z-score is 1.5.
Yep.
Yeah.
Okay.
Assuming they both tests measure the same kind of ability, who did better in mathematics section? Explain why.
Eleanor's z-score was higher.
I would say that
Yeah,
Eleanor?
did better.
Yeah. Yep.
Why would you say that? Is it just because it was 1.5? I'm just looking at my math score. It's 680. And she had 800 questions. This says explain.
So since her number is bigger than Gerald's, she is in a higher percentile than he is. She, instead of her being in like the 68th percentile, she moves on to like the 95th percentile or something like that. If you look at a bell-shaped graph. Does that make sense?
Yeah. I'm just reading ahead the next question.
Okay. Do you want to read it?
Yeah, the label on the Chocolux candy states that it has a net weight of 87.75 grams. Due to the natural variability of the manufacturing process, the chocolate bars do not all weigh exactly 87.75 grams. In fact, the distribution of weights is approximately normal with a mean of 90 grams and the standard deviation of 0.75 grams. Use the information to answer 15 through 19. Compute the sentence about 95% of the Chocolux candy bars will be between. Okay, so do we take that 87.7 grams? Which ones are we doing it like with a z-score? Are we taking the 87 and the 0.75 and the 90 grams and using that in the calculations?
No, you're just adding so the mean is the 90, and so to get to the 95th percentile, you add 0.75 to 90, you get 9.75, then you add 0.75 again, you get 91.5, and that's the 95th percentile on the right. And then you do the same thing to the left and you subtract it.
Okay, but and just do it like when you did the first one and you look at all the answers, you can automatically kind of know it's B because that's the only one with that 91.5. But I mean, going on and doing the rest of the math just to confirm it.
Yeah. So it is B because the answer is 88.5 on the other side. Okay, so 16 says, what proportion of the bars actually weigh less than 87.75 grams? In other words, what portion of the customers is getting less candy than they should? So are we using the applet on this one?
Yeah, it says to use it. I just couldn't find it in all my tabs.
Okay, oh, someone's. Okay, so are we putting in that? Let's see. For the applet.
Where's my homework?
Did you guys get a z-score to put in? Let's see.
Use the applet, okay. So what portion of bars actually weigh less than 87.75 grams? 87. So,
Hello?
I'm here.
I can't hear any of y'all. Can y'all call me back?
if we call you back, then we have to restart this, don't we?
So can you not hear us at all, Eddie?
He should be able
Like
to come
very
back
little. I
on.
don't know why. Here, let me try to put on my headphones. Maybe it'll work.
So with this one, are you just taking like due to natural, like the variety, the chocolate bars do not weigh. In fact, the distribution weight is 90 grams and a deviation of 0.75. So the mean is 90.
Okay, I got the answer.
So what did you do?
Okay, so they gave us the X, which is the, let me go to the homework, which is the 87.75, so that's the X. The mean is 90, and the standard deviation is 0.75. So you do 87.75 minus 90 divided by 0.75, and then you get your z-score, which is -3. And you plug that -3 into the applet.
The applet.
To get the z-score. And then the area on the top is 0.0013.
Okay, so what did you have for the standard deviation under what you divided the 87.5 and the 90?
0.75. It says the standard deviation of 0.75.
Up there. Okay. The grams.
Does that make sense?
I just lost my homework. I don't know where it went. On the applet, the -3 that you put in, that wasn't the area, right?
No, that's the z-score.
You put the -3
at the z-score. And then your area is 0.0013.
Okay.
Got it.
Where did my homework go? Oh, positive.
Okay. And I'm going to go back. 17. What is the probability that the weight of a randomly selected candy bar will be greater than 91.3 grams? Give your answer. Okay. Then would you just do basically the same thing and plug it into...
You do 91.3 minus 90 divided by 0.75.
Mm-hmm.
And then you plug the 1.73 as your z-score. You want, so it's 0.4. Nope, that's wrong. I think it's this one right here.
Wait.
0.4.
I have the 0.958. Why do I have?
Because you need to take off the middle portion. You only want the right section on this one.
Thank you. Oh, because we're talking about above.
Yeah, you're talking about greater than.
Yeah, that was something too when I met with Soraya yesterday. She talked about, and she talked to us about, is just really watching the wording, because that will change everything.
What did you find for your z-score?
My z-score was 1.73.
33333.
And then you got 0.0418.
Mm-hmm.
Okay, how did y'all do that again? Sorry.
I got 1.5.
You got 1.5?
Well, I got 0.0415. But how many threes did you put? What'd you put in your z-score box? I went 3 decimals over.
1.73.
Okay, that's why I got that, because I just went another 3. I went 3 decimals over.
It still rounds up to point.
I have 1.8.
Yeah, I have 1.8.
How'd y'all do the math again?
Okay, so the x value that they give you is 91.3, and so you subtract that from the mean, which is 90, and then you divide that by 0.75, which is the standard deviation. And so your z-score is 1.73, and you put that into the applet.
Let's see. Okay.
Okay, yeah, because the answer is 0.042. That's what they're saying. All right, let's get going on these others.
All right. Number 18, what is the 66th percentile of weights of the Choco Lux bars? Give your answer to 3 accurate decimal places. Okay. So
I have to go get a plug-in.
Okay.
Is that 90.3?
Yeah, how'd you get that?
So the X is what's missing. So the Z-score will be 0.412. So you use the 0.66 to plug it into the applet
Uh-huh.
on top, and 0.66 would be the 0.412 as a Z-score, positive.
That's what I did.
So you have the 0.412 as a Z-score equals X minus 90, which is the mean, over 0.75, which is the standard deviation, and solve for X.
Okay.
What was the standard deviation? You do X minus, did you say 90?
Over 0.75.
90.3. Okay. Sweet.
If it wants 3 decimal places, do we put 90.309?
Yeah. Number 19 says, what does it mean that the weight of the Chocolux candy bar is at the 66th percentile? It means that the Chocolux candy bar is heavier than 66% of the candies?
Yeah.
It's talking about weight.
Right?
It's 90.3, it's just a 0.3 grams heavier.
So so it's heavier than 66% of the candies. Let me see what the answer sheet says. Says the candy bar is heavier than 66% of all other candy bars and lighter than 34% of all candy bars. Right. Do we all get this?
Pretty much. I'm gonna talk to Soraya about it some more, and then do some reading over it on that thing.
I usually watch the videos, and it's been crazy. I haven't watched the videos, and those help me so much.
Yeah, it helped me out a lot this time.
Yeah, I definitely need to do that because they go through it step by step, and that's awesome.
Yeah. All right. Should we attempt the quiz now?
Yeah.
Do it.
All right. Let's do the quiz. You guys ready?
Yeah, I just opened it up.
Okay, me too.
Yep.
The first 2 are easy.
Should all be like this.
Okay. Oh, that's nice. Just click on that normal applet right there. It just brings it right to the side in the next tab over.
Cool. So it says, first one, the total area under a normal distribution curve must equal 1. Dang, I don't like it when these don't have multiple choice. That's the only one.
Under certain circumstances, a normal distribution curve can drop below the x-axis.
That's false.
Yeah, you said that. That was in the video. So.
A normal distribution curve is symmetric. True.
So it's symmetric or bell shape, right? Is that what it is?
Yeah.
C?
C.
Yes, C.
C for z-score.
Number 7.
Which of the following elements of the figure represents a probability that the z-score will be greater than 1?
A none. Right? Yeah,
B.
it'd be none.
Isn't it B?
Would B be more than B?
No, because all of these right here equal to 1.
Oh, that's right. So it's true because B would be a percentage. It would be like area. It would be an area, and it would be
Yeah.
a point. So.
Mm-hmm.
According to the 68, 95, 99.7 rule, what percentage of the data from the bell-shaped distribution will be within 1 standard deviation of the mean? Write your percentage as a percentage such as 42 rather than a proportion such as 0.42.
Okay, it'd be 68. Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -1 and 1? Give your answer as a decimal accurate to 3 decimal places. If the answer was okay, so 3. So we just put 1 in for the z-score.
And then
It's already there.
yeah.
Mm-hmm.
So it says,
So it's the 0.31.
yeah, 0.317 would be the answer.
0.317. They just want to make sure we're doing it, like we've opened it.
Maybe.
So just go out to the 3.317.
Yeah.
Okay. Now do it with
-2.
-2.
It's just completely went away, so keep going and I'll.
The 0.045.
0.046.
Or, yeah, bring it up to a 6.
I like this quiz a lot.
This quiz is great.
Watch, the very last question is going to suck.
Hey, for this, where it says what portion of the z-scores will be between -2 and 2, do you just highlight the middle part?
I didn't even mess with it.
I just got the area.
The two sides are
wrong.
Something it's 0.95.
Yeah, that's a good catch because it is the middle part. Because if it was less than, it'd be the left. If it was greater than, in between is the middle.
So the 0.95.
So for question number
10.
9. Should we go back to that?
For question number 9, the answer would be 0.683. Then.
Yeah.
Yeah, because I didn't even mess with it. Say that again for the 9.
For 9 it is 0.683. Good catch. That's good.
Hey, can I go back through it with you guys? My computer threw me out.
Yeah.
Number 1 is 1.
We can go back over all the answers.
Okay, I'll just start where you guys are at. And you are on 9?
Yeah, on 9.
Okay.
And that was the 0.683.
9 is 0.683, yes. Number 10 is 0.955.
Now we got to see what they want us to do. The proportion secret will be between So keep it in the between.
Yeah, I'm just keeping between the between. And then
Now put in the 3.
it's 0.997.
Mm-hmm.
Mm-hmm. We're good. Look carefully at your answers to the last 3 questions. What do you observe?
I would say that they follow the 68, 95, 99.7 rule.
The last,
Yeah.
oh, the questions before. Yeah. Well, obviously, because it's going with the bell curve.
And the answers are 0.68, 0.95, and 0.997.
Okay, so it's the values match the 68 rule thing.
Mm-hmm.
Okay.
I'll read the next one.
Okay.
Here's the following information to answer the next 6 questions. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirements is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is 0.65, and the population standard deviation is 0.07.
Okay. So what proportion of the population will have a protein requirement that is less than 0.6? So it would be 0.6 minus 0.65 over -0.07. Okay. I got 0.238.
And let's see. Okay.
How'd you get that?
So I did 0.6
Uh-huh.
minus 0.65
Uh-huh.
divided by 0.07. And I got negative 0.714, and that's the z-score. And so I put that into the applet, and I clicked on the left.
Okay.
And then the area is 0.238.
Yeah.
Is that good?
You get the less.
Yep. I thought it was positive, so I was looking at the other side.
Okay.
What proportion of the population have a protein requirement that is more than this time, a 0.60, give your answer in decimals.
So that would be the 2 right ones, right?
So you just click on those, yeah, just switch it.
So
What does that say?
0.762.
Mm-hmm.
Okay. So this time you plug it in with less than 70 grams.
grams.
Oh. Oh, yeah. No, okay, good. Less than 70, yeah.
What did you get for that one?
0.762.
Mm-hmm.
Okay.
So it's the same one as in question 14? Okay, 16. Find the probability that a randomly selected person will have a protein requirement that is between 60 and 70. First area between the two values. Okay, so it would just be 0.524, 0.525 actually, right? Because it's just the middle.
If you click on just the middle section.
Yeah.
And what is that one?
It's because you take away the smaller and you take away the larger.
So I got 0.525.
Back in 15, I just put 0.76. Was there a third decimal in there?
And 53, it's 0.762.
Thank you.
So.
Find the 35th percentile for the protein requirement for adults. Round to the nearest decimal.
Okay, I got 0.682.
How did you do that?
So this is the one, this is just like the one Eddie explained. I put 0.35 in the area at the top of the applet.
Uh-huh.
And I kept this middle section shaded.
What's the z-score that you have?
0.454. Did you get the same thing, Eddie?
Yeah.
Okay.
You just highlight the middle and then put the percentage on top.
Mm-hmm.
Okay.
All right. And the last one, find the 80th percentile. So on this one, are we going to have both of them, the left and the middle one, shaded?
Let me see.
I would think so with the 80th percentile, right?
Yeah. So I think it'd be the left and the middle.
Okay.
In the area, sorry you guys, are you putting that 80th percent?
I'm putting 0.80. Put it in as a decimal.
If it's 80% of the population,
It's 80% of the protein requirement for adults.
Yeah, because just the middle portion is 68. but if you add the left portion to it, it goes up to 81.5. So I'm assuming we add up the left. I got.
So are you talking about the 0.9?
Well, I just highlighted the left and the middle.
Percent of the population.
So using the left and the middle, did you get the 0.90? 90?
I don't think that's how you do this ones.
So let's see.
I think this is the ones where you just like highlighted left 2, which is, and you'll put 0.80%, and that'll be your.
That's what I did.
And that's the 0.900, right?
Well, but then that'll be your 0.842, and then you solve for x.
Yeah, that's what I did. And then you get 0.709, right?
No, no. Haven't done it yet.
Okay, what was the math again?
So you're going to do 0.842 is equal to x minus 0.65 divided by 0.07. So you're going to multiply 0.842 by 0.07 and then add 0.65 to that.
Yeah, and I got 0.709.
Yeah.
0.09, and 17 was 0.454. Right?
17 is 0.454?
Or what did you get?
I put 0.682 because the 35th percentile is still included in the 68th percentile, isn't it? Because I put 35, I had the middle section, and then I put 0.35. I got 0.454 as the z-score, and so then I solved for that.
Wouldn't
X minus
wouldn't the z-score for that be 0.38?
I got 0.682 again.
So you put in 35% of the population. You would highlight the left too, right? And then put as an area of 0.35.
You might be right. I don't know, actually. We can do that. That probably would work just fine. 0.35. Then you get a 0.385 as your z-score. 0.385. And you got 0.678.
I'm still working that one out. What is the mean again?
The mean is 0.65.
And the standard deviation?
Is 0.07.
.677?
0.677, yeah. So do you want to change that one then, number 17?
0.677, not 0.678.
Yeah, 0.677.
We have 2 chances on
Yeah.
this, so that's a good
Yeah,
thing.
so if we don't get it right on here, then we know what we did wrong, hopefully.
I want to
And
go back to a
18
couple
was
of the answers.
and 18 was 0.709, right?
Yeah.
Okay.
Okay. So for question 3, Donna,
Mhm.
it's 1.
Great.
For 4, it's false.
Mhm.
5 is true.
Mhm.
6 is C.
Okay.
7 is none of these.
Okay.
8 is 68.
I think I have it at 68.683, 0.995, 0.997. A
10, I have 0.955.
0.995. Okay.
No, 0.955.
Oh, 0.955.
Yeah.
Okay. And then 11 is 0.997.
Mhm.
12 is A.
The values match.
Yes.
Okay. Mhm.
And then I have 0.238, 0.762, 0.762, 0.525, 0.677, and then 0.709.
Yep. All right, let's see how we did.
I'm gonna cringe a little bit.
Ooh, we missed 1.
Which one did we miss?
We missed 2.
Oh.
So we got a 90.
Which of the following elements figure represents the z-score? How do we? Oh, that one I didn't miss that one. I'm sorry. Following elements represent the z-score is greater than 1.
Well, I guess we were wrong about 7.
Right. Which of the following elements of a figure represents?
I'm going to write down all the answers so that we don't have to redo them again, because they're the exact same if you retake it. Okay, so it's 1. Okay, you guys ready to retake it?
Yeah.
Okay.
F.
Are you guys all ready?
Yep.
Okay, so for number 3 is 1.
Mm-hmm.
Number 4 is false. 5 is true. 6 is C. And then we got number 7 wrong. So it's either A, B, or C.
It's B.
You think it's B?
That's the one that we were thinking of, huh? That we were.
Okay. All right. Question 8. Is 68. Question 9 is 0.683.
.683. I was just going to say, you guys, I didn't click on it the first time, so I'm still on my first attempt. So if you want to, before you guys click on it, I could check mine just to confirm that we got it all correctly.
Okay.
No, 8 was 68, right?
8 is 68.
Okay.
Number 9 is 0.683.
Mm-hmm.
Number 10 is 0.955. Number 11 is 0.997. Number 12 is the values match. Number 13 is 0.238. Number 14 is 0.762. Number 15 is also 0.762. Number 16 is 0.525. Number 17 we got wrong, but the answer we had before was
Your number.
yeah, I'm going to find it. I think it was 0.682. No.
I think
0.687. 0.68. It was 0.682. That was what I had before, I think. I think I'm going to redo it.
And like I said,
yeah.
I'll go ahead and submit it to just confirm if we got it all right.
Okay, yeah, I think
So
17 was 0.682.
And then 18 is.
And 18 is
0.709.
What is
What was
18?
Okay, don't
0.709.
submit it yet, you guys. Let me submit first, since I didn't do the first attempt yet.
The first one was, or number 17 was 0.677. That's what we had last time.
Yeah, so 0.682.
That one's still wrong.
The
So don't submit it
0.682?
yet, you guys.
Okay, I might have it
that's
wrong.
the only one.
That was wrong?
Okay, that one's wrong.
Okay.
Everything else is correct.
Let me
I'll keep this. I'm gonna get another tab up to redo my second attempt. I think if we always have someone do this, this way at least we'll always get 100% on these quizzes.
Okay, so that is wrong. So if that's wrong, maybe we're supposed to have the first 2.
No, I don't think so, because 35% would be the left shaded one only.
Well, we know that one is wrong, and we know that just the middle one is wrong as well. Maybe we're supposed to be doing
You know what? Maybe we had to put negative.
Negative 35%?
Z-score.
No, the z-score does it automatically negative if you put it in. One's
No, but
always
if
negative and one's...
If you're highlighting the left side, that's the negative side of the z-score.
Yeah, so if you put 2, it's still going to be negative 2. Do you get what I'm saying?
Give me 1 second.
Maybe we're supposed to do 0.65.
I'll be right back.
And 30th percentile of the protein requirement for adults. Oh, so I think we're supposed to be doing
Yeah,
0.65. Or we're supposed to be highlighting the right portion. But if we highlight the right, it's the exact same as the left.
So for the math, it would have to be negative 0.385 equals x minus 0.65 over 0.07.
You think we're using it negative?
Well, I think so. Well, either way, the answer will be positive. But I got 0.623.
Yeah. Times 0.07.
Why did you do that?
It was the z-score, which is negative 0.385
Right.
equals x minus 0.65 over 0.07.
I can see how that could be right. Do we just want to submit it already, guys?
Yeah. So it's 0.623, right?
Yeah, 17.623.
0.623. Because I'm redoing my quiz, filling it all in. Okay. Let's see. Can you guys just, let's see, question 7. I'm at question 7. Let's see, what was...
It's B.
Which is, it's B. Okay. 8. What was 8?
68.
0.68?
No, just 68.
Or no, just 68.
Yes. 68.
9
is 0.683.
683.
10 is 0.955.
0.995.
No, 0.955.
55.
11 is 0.997.
997.
12 is the values match. 13 is 0.238.
0.238.
14 is 0.762.
762.
15 is also 0.762.
762.
16 is 0.525.
525.
17 is 0.623.
0.623.
And 18 is 0.709.
0.709. Okay.
All right. Shall we see how we did?
Thank you.
Nice. Good job, Eddie.
Yay.
We keep our streak. Sweet.
So with that one, we went to the right side of the applet, right? Is that how we figured that one out?
No, we went to the left. Just that when we did it the first time, we used the positive version, which is the right side instead of the negative.
Okay.
Yeah.
Great. And it says right under the z-score that -3, and we should just use that value. We are highlighting that side. Okay, that makes sense now.
Sweet. All right, good job, guys.
I'm going to go watch some videos.
That sounds good.
Thank you, everyone.
All right,
Yeah.
thanks.
All right, bye.
Bye.